Chapter 7, Section 1, Zero and Negative Exponents. If you are watching this, then you can pause the video and go ahead and grab a calculator and try plugging in all of these problems into the calculator and write down the answers that you get, and then you can click play again, or you can just keep watching. So if you had a calculator and you plugged these into your calculator, for the negative exponents, if you see 2 to the negative first, 2 to the negative second, 2 to the negative third, I want you to try to write those as fractions if you can. If you get decimals, then that's okay, because the decimal will have a fraction equivalent. 2 to the third power, remember exponents, when they're positive, mean repeated multiplication. So what that means is 2 times 2 times 2. 2 times 2 times 2 is 8. 2 squared is 4. 2 to the first power is 2. 2 to the 0 power, and this is where you might not know what this is, but if you plug it into your calculator, you get 1. And then these negative exponents could possibly be new also. I'm going to write them as fractions. Depending on how your calculator is set up, you might get a decimal, but this should be the fraction equivalent. So 2 to the negative first power is 1/2. 2 to the negative second power is 1/4. And then 2 to the negative third power is 1/8. Looking at this table, you should be able to notice something. 2 to the first power was 2. Well, 2 to the negative first power was 1/2. 2 squared was 4. 2 to the negative second power was 1/4. 2 cubed was 8. 2 to the negative third power was 1/8. So what happened was when I had the whole number 8 for 2 to the positive third power, that 8 becomes the denominator under 1 when I have 2 to the negative third power. And this is a pattern that is true. This is a pattern that you will see. Go ahead and try the tens as bases. 10 to the third power is 1,000. 10 squared is 100. 10 to the first power is 10. 10 to the 0 power is 1. 10 to the negative first power, I'm sure if you look at the last table that we did, you could make an educated guess here, and you would probably be correct because hopefully you would say 1/10. 10 to the negative second power is 1/100, and then 10 to the negative third power is 1/1000. This is going to be true for all of your bases with the exception of 0, and we will talk about that in just a minute. If you notice those two, 2 to the 0 power and 10 to the 0 power, both of those are 1. These two ideas that we can get from this table is what we're going to talk about today, which is the properties of zero and negative exponents. First, let's talk about the property of zero exponents. For any non-zero number a, notice a is your base, which means it's the number being raised to a power. A to the 0 power is always going to be 1. So if you had 1,000,000 to the 0 power, it would be 1. If you had negative 1,000,000 to the 0 power, it would be 1. Or if you had like 1/1000th to the 0 power, it is going to be 1. 0 to the 0 power, or which is written in parentheses using notation, is always going to be undefined. The reason why it's undefined is it kind of has two sets of rules. 0 to any power, except for 0, is going to be 0. So if you add 0 to the first power, that's 0. 0 cubed would be 0. 0 to the 100th power would be 0. But then we also just said that anything to the 0 power is 1. So there's two different properties that are working against each other here when we have 0 to the 0 power. And for that reason, it can't be 1 and it can't be 0. And for that reason, it's just going to be undefined. It's not going to be able to have a solution. The property of negative exponents says that for any non-zero number a, an integer n, a to the negative n, when n is negative, is going to be 1/a to the positive n. So what happens is we can take a to the negative n, we can set it as a denominator under 1, and that makes my exponent become a positive exponent. Again, there's an exception for 0. 0 to a negative power, or 0 to the negative n, is going to also be undefined because 0 would become the denominator, and you cannot divide by 0. When you're trying to divide by 0, your answer is undefined. So for both of these sets of rules, and it's not always true, it's only true for 0 and negative exponents. When 0 is your base, it's going to be undefined. But if you had like 0 cubed, that means 0 times 0 times 0, which is just going to be 0. So 0 to a power is not always undefined. 0 to a power is undefined when your power is 0 or when your power is negative. What is the simplest form of each expression? A is 6 to the negative second power. Using the property that we just talked about, the negative exponent power, negative exponent rule, we can write this as 1 over 6 to the positive second power. And because 6 is a number and I can square it, I'm going to go ahead and write it in simplest form, or do 1 over 6 times 6, which is 36. So simplified, 6 to the negative second power is 1 over 36. B, we have negative 9.3. Notice that it's in parentheses. So the whole thing, negative 9.3 to the 0 power. Well, we just said that anything except for 0 to the 0 power is 1, so negative 9.3 to the 0 power is 1. This next example says, what is the simplified form of each expression? If you notice here, I have in A, I have 3a to the negative second, b to the third. What I need to do here is only one of these is to the negative exponent, has a negative exponent, so I need to take a to the negative second and write it with a positive exponent by putting it under 1. 3 and b to the third power, or b cubed, are going to be left alone. They're just going to stay whole. They're not going to become a denominator. They're just going to stay whole numbers out in front. So I would have 3b cubed. Nothing happens to that because they have their positive exponents, times 1 over a to the positive second power. I can go ahead and multiply these. You could write 3b cubed over 1 and multiply numerator times numerator, denominator times denominator, and you would get 3b cubed over a squared. The next example says next example B is 1 over x to the negative sixth power. I'm going to go ahead and I'm going to rewrite this using my division sign. So I'm going to have 1 divided by x to the negative sixth written like this. What I can do now is I can go ahead and I can write x to the negative sixth using a positive exponent by putting it under 1. Well, if I'm trying to divide by a fraction, remember we can't divide by a fraction, we have to multiply by its reciprocal. So I actually am going to rewrite this as 1 times a positive x to a positive 6 over 1. And when I multiply anything by 1, it just stays itself. So the final answer would be x to the positive 6. Now that we've gone through all of those steps, if you see 1 over x, or a number to a negative exponent, you can just know to go ahead and bring that up to the numerator and make it a positive exponent. We've kind of proven it right here, so I'm going to be okay if you just see it and you're like, oh, it's under 1 and it's a negative exponent, so I need to bring it up on top of the numerator to be in the numerator with a positive exponent. This next example says, what is the value of 2a to the negative second times b to the fourth for a equals negative 2 and b equals 1? If you notice, again, I have a negative exponent. What I need to do is rewrite using positive exponents before I substitute in the values given for a and b. So before I substitute in negative 2 for a and 1 for b, I'm going to go ahead and rewrite this as 2b to the fourth. I don't need to take those down to the denominator because they both have positive exponents, over a to the positive second. I've brought it down to the denominator because it was a to the negative second, which means I can put it underneath my other numbers with a positive exponent. Now I'm going to go ahead and plug in -2 for A and 1 for B. Make sure that when you're plugging these in or substituting, you put them in parentheses. -2 squared in parentheses is different from -2 outside of parentheses squared. That means you're taking -2 times -2 instead of just -2 times 2. So go ahead and now it's just order of operations. So go ahead and get rid of your exponents. 1 to the 4th is just 1. And then -2 squared, -2 times -2 is a +4. That's where the parentheses came in handy. 2 times 1 is just 2. So we have 2 over 4, which can be simplified to 1 over 2 by dividing by 2 on both the top and the bottom. A population of birds doubles every 8 years. The expression 6,400 times 2t, 2 to the t power, models a population of 6,400 birds after t periods of 8 years. Evaluate the expression for t equals 0 and t equals -2. Describe what each value of the expression represents in this situation. Because t is the period of 8 years, t being equal to 0 is going to mean that 0 periods of 8 years have passed. So think to yourself, what do you think that would mean for the bird population? If 8 years have not passed yet, what's going to happen to the number of birds, considering it doubles every 8 years? So go ahead and plug in 0 for t, which would be 6,400 times 2 to the 0 power. I can use my exponent rule that I just learned, which is anything to the 0 power is 1. So 2 to the 0 power is 1, which means I have 6,400 times 1, which gives me 6,400 birds. When t equals 0, the bird population did not change, which hopefully is what you had thought of. T equals 0 is showing the growth of a population after 0 periods. So the population has not changed, which should have been what we expected to happen. Think about what -2, plugging in -2 for t means. -2 means that we're going back in time. It means we're actually going back to 8-year periods. What would that mean for the bird population? Think to yourself, hopefully, maybe jot it down. But going back in time usually would mean that the population would what? Go ahead and plug it in and see what happens. So we would have 6,400 times 2 to the -2nd power. We can go ahead and write 2 to the -2nd power is 1 over 2 squared, which 2 squared is 4. So 2 to the -2nd power becomes 1 over 4, or 1/4. So we have 6,400 times 1/4. Multiplying by 1/4 is the same as dividing by 4, which leaves us with a bird population of 1,600. Again, hopefully this is what you had expected to happen. T equals -2 is showing the growth of population before the 6,400 population. So the population has decreased as expected because this was before our population had grown to 6,400, so it had to be less than 6,400. Today's assignment is on page 446, numbers 1 through 8, and then 10 through 44 even.